Hello lovelies, in this video the brilliant Mr. B is going to be looking at the chain rule and working through lots of examples using it for you. This is for your A-level maths. Now there are lots of examples here, work through really slowly so you can pause the video, work at your own pace, jump in, jump out as you see fit. There is no one watching you, no pressure from anyone else, no pressure from the teacher. Take your time with this. Use these as the worked examples, use these as practice questions, and then when you want to test yourself a bit more, over my website there are loads of questions with worked answers for you just waiting to help you improve.
We are going to have a look at the chain rule for differentiation, and first we're going to review all the different rules of differentiation we've covered so far. So let's say we have a curve, y equals 2x minus 8 squared, and the first method is just kind of regular differentiation. That only works when we've got terms separated by pluses and minuses, and we've got brackets and a squared here. So what we want to do is expand the brackets first. So we have 2x times 2x is 4x squared. 2x times negative 8 is going to give us negative 16x, and we'll end up with two of those, which will be negative 32x. And negative 8 times negative 8 is going to give us positive 64. So now we've kind of manipulated this to get terms separated by pluses and minuses. Now we can use our regular differentiation. So we get dy by dx. It's going to be the gradient of this curve. So we do 4 times 2 is 8 and reduce the power by 1. If it's just x, it's x to the power 1. So 32 times 1 is 32. And you reduce the power and you get 0. And the 64, there's no x there, it means it's x to 0. And 64 times 0 is going to give us 0. So we lose just our number term at the end. So our answer is 8x minus 32. So we can do this using regular differentiation, but we have to manipulate what we've got first to be able to do it. And that's something we can do when we've just got kind of y's and x's. But you can get things, particularly when you look at trigonometry, you look at logs, you look at the number e, where you can't do this. So we need other methods. So the first method we looked at was the product rule. So doing this with the product rule, again, it's going to be the same line, because we're going to see we get the same answer. And what we've got here is something multiplied by itself. So it's y equals 2x minus 8 multiplied by 2x minus 8. That's what the squared sign means. And so what you do with the product rule is that you differentiate each bracket separately, and then you use a formula to piece it back together. So we'd say that u is equal to the first bracket, v is equal to the second bracket, and then we differentiate those for u dash and v dash. So 2x is going to become 2, and negative 8 is going to go away. And they're both the same, so you get the same answer. So when we get a differentiated version, dy by dx, it's going to be u multiplied by v dash, which is going to be 2 lots of 2x minus 8. You're going to add to that v multiplied by u dash, which is going to be 2 lots of 2x minus 8. So altogether, that's going to be 4 lots of 2x minus 8. So I've not written the formula down here, but essentially you multiply u by v dash and u dash by v. So you multiply the kind of regular version by the opposite differentiated version. Now it looks like a different answer, but what if we expand these brackets? 4 times 2x is going to give us 8x, and 4 times negative 8 gives us negative 32. So we've got the same answer. But while this is more working out, again, there's going to be situations, trigonometry, with logs, with e, where you actually can't do the first solution. So you have to do the second solution. Now, that brings us on to what we're going to be doing today, which is looking at the chain rule. So the chain rule, again, I'm going to start at y equals 2x minus 8 squared. And this is kind of all about the power and differentiating when you've got something with a power. So what we're going to do is we're going to change this into y equals u squared and u equals 2x minus 8. So we've kind of separated the power and then the thing the power is raising. Once we've separated these, we're then going to differentiate them. So we have dy by du equal 2u. I'm going to have du by dx is equal to 2. And so I'll just differentiate it. Now you might wonder about the y's and the u's and the x and the d's. So basically the numerator is what's on the left-hand side. So you got y on the left-hand side, it's dy. You got u on the left-hand side, it's du. And the thing on the denominator is the thing on the right-hand side. So if you've got u on the right-hand side, then it's over du. You've got x on the right-hand side, then it's over dx. So we split it up power and terms separately, and then differentiate them separately. And then we're going to combine them. And the way you combine them is that dy by dx is going to be equal to dy by du multiplied by du by dx. So if we do that substitution, dy by du is 2u, and du by dx is 2. So our answer is 2 lots of u times 2. Well, what does that mean? Well, actually, we know what u is, and we can substitute u in. So let's make a little bit more space. So we've got 2u times 2. Altogether, that's 4u. So we're going to have 4 lots of u, which was 2x minus 8. And again, it doesn't look like our answer, but we expand the brackets. 4 times 2x is 8x, and 4 times negative 8 is negative 32. So all 3 methods get us the same answer. We've got regular differentiation in blue, but we've got to kind of prepare what we've got first to be able to do it. We've got the product rule in green, but again, we've got to kind of slightly change the wording of the question to make it a multiplication rather than a power. And then we've got the chain rule in pink. And again, you might be thinking, well, the chain rule looks like it's a lot more effort than the other 2 methods. And you'll be right for this question. But again, you can get trigonometry, you're going to get logs, you're going to get E. And when you differentiate those things, you might not be able to use the previous 2 methods. Or it might be, it's not going to be a power 2, so you can rewrite it as 2 things multiplied, like we did here with the green one. It might be it's a power 5 or a power 6, and it's not practical to do the product rule multiple times to be able to get your answer. So we're going to practice using the chain rule on easier questions that, yes, you could do in another way more quickly, but then that will lead to being confident when we look at logs and trigonometry and the number E. So let's go through example with chain rule. And first, let's write down chain rule. It's dy by dx is going to be equal to dy by du multiplied by du by dx. And that's going to look a little confusing, but think about doing the multiplication. If you multiply this out, you'd have dy times du divided by du times dx, and then you can simplify and get rid of the du. And that's how you're left with only the dy and the dx, which is how we write differentiation. There's a difference in y over the difference in x. Now, our differentiation is obviously a little bit different, so we need to get a u involved in this somewhere. So we've got our expression, 5x cubed plus 2, and it's all squared. So the best thing to do is write it as if it's a line. So we've got y equals 5x cubed plus 2 all squared. And so what we want to do is do a dy by du and a du by dx. So we want the difference in y over the difference in u. So we can write y is equal to u squared. So we've replaced the entire bracket section with the u. Then we're going to multiply it by a difference in u over a difference in x. So we're going to write u is equal to, and then whatever we took out for u. So that's the 5x cubed plus 2. And now we differentiate. So dy by du is going to be equal to 2u, and du by dx will be equal to 5 times 3 is 15, reduce the power, and we're going to lose the 2. So all we need to do now to get dy by dx is multiply those 2 together. So that's going to be 2u multiplied by 15 x squared. So next we can do the multiplication. 2u times 15x squared, 2 times 15 is 30. So we have 30 x squared u. And then all we need to do now for our final step is to substitute the u back in. That's going to give us 30x squared multiplied by u, which is 5x cubed plus 2. And we can leave that as our final answer, or you can try and manipulate this further to get it into different forms. So for example, one thing we could do is we'll try and multiply it out. So 30 times 5 is 150. X squared times x cubed gets to the power 5. And then 30 times 2 is going to give us 60. So you could completely multiply it out like that. Alternatively, we could factorize it in different ways. So, it all depends on what the next step is, what the question is actually asking for. But I'm not going to do a lot of manipulating the final answer here. I'm just going to concentrate on the chain rule section. So I'm going to leave my future answers in the brackets, but just be aware there are possible additional steps. So moving on to our next question, we have y is equal to x plus 1 cubed, and we want to introduce the u into this. So we can have y is equal to u cubed, and u is equal to x plus 1. So again, we've separated the power and the thing the power is increasing. Now we want to find dy by dx. So to do that, we need to multiply dy by du and du by dx. So the difference in y over the difference in u, we'll bring down the 3 and reduce the power by 1, and we have 3u squared. Then for u equals x plus 1, that'll be du by dx. So again, just a reminder that the numerator 1 is on the left-hand side, and the denominator 1's on the right-hand side. So we have u on the left, we'll find the difference in u, and we have x on the right, we'll find the difference in x. And so if you differentiate x, you get 1. You differentiate 1, you get 0. So now we've got these. We need to multiply them together to get dy by dx. So that's going to be 3u squared multiplied by 1. If you multiply something by 1, it's not going to change. But then we want to put the u back in. So that'll be 3 lots of our u, which is x plus 1, and it's going to be squared. Now, again, there could be additional steps after this. So we could multiply out the quadratic, we could multiply it by the 3. There's things we can do next. But we've done the chain rule portion of the question. Moving on to the next example, y is equal to 5x minus 8 cubed. So we're going to split that up into a y section and a u section. So y is equal to u cubed, and u is equal to 5x minus 8. So we see all the elements of the original are still present. We've got the 5x minus 8, we've got the cubed, we've just split them apart into separate sections. So then we differentiate. So we differentiate y equals u, you get dy over du, and that's going to be 3u squared. We differentiate u equals x, you get du over dx, and that's going to give you 5. So if we want dy by dx, we have to multiply dy by du and du by dx, which means that the u's get cancelled out, and we're only left with the dy by dx. So that's going to be 3u squared times 5, and we can do that. 3 times 5 is 15, so it's going to be 15u squared. All you have to do for the final step is put the u back into the equation, because it's dy by dx, so you've got to have the x in there. That's going to be 15 lots of u, and u was 5x minus 8, and u was squared. Now, again, that could be the final answer, but there could be additional steps. You could expand the quadratic, you could multiply through by 15. So there could be other things to do next. Again, this is the chain rule part. So for our last of these examples, we've got y is equal to 8x squared minus 5 cubed. So we want to change this into y equals u, and then you want u is equal to x. Then you can see the two sections, u cubed and 8x squared minus 5. We've got all the elements of the original that are split into two sections. And if you substitute u back in, you get your original equation back. So I've not changed anything yet, I've just changed the way it's written. So now we can differentiate and find the difference in y over the difference in u, and that would be 3u squared. So bringing down the 3 and reducing the power. Then we can find the difference in u over the difference in x. So we can bring down the power. 2 times 8 is 16. Reduce the power by 1. And then a negative 5, that's been multiplied by 0 to get 0. So now we can do the difference in y over the difference in x by multiplying together two previous answers, because then the du is going to cancel out. So that's going to give us 3u squared multiplied by 16x. So altogether, 3 times 16 is going to give us 48. So it'll be 48x u squared. And then we need to substitute the u in, and u is 8x squared minus 5. Now, again, this is not necessarily the final step. You might want to expand the brackets, so we factorize it in a different way. But again, this is the essence of doing the chain rule and then getting an answer for the chain rule. And then again, there might be things afterwards. So next, we're going to have a look at the chain rule with trigonometry. And we have y equals sine of 6x plus 7. Now, there's no powers here, but we can use the same principle as a chain rule and can split this into two sections. So we can say we've got y is equal to sine u, and u is equal to 6x plus 7. So the chain rule is not limited to a power, it's limited to kind of a function happening to something. So in the previous cases, our kind of little x term, that was having a power happen to it. In this case, our little collection of x terms here, the 6x plus 7, that's having a sine happen to it. So we can do this the same way. We can find dy by du. And if you differentiate sine, you're going to get cos. Remember, the angle bit stays the same. In this case, it's a u. And then we can find du by dx, and that's just going to be 6. So when we find dy by dx, we need to multiply our two answers together. It's going to be cos of u multiplied by 6. So So we can write that as 6 cos u, and then we can substitute the u back in. So that's going to be 6 lots of cos 6x plus 7. Now, if you look at the two answers, you'll notice the angle part, the 6x plus 7, it hasn't changed from the original question. And so all when differentiating, I've been saying, the angle part doesn't change, we differentiate trigonometry. And through use of the chain rule, you can see why that is. You can see why that's happening. For our next example, we have y is equal to sine of 2x squared plus 3x. So we want to separate these two bits out. So we're going to have y is equal to sine of u. So the y equals bit, that's going to be the thing that's happening to the x term. And then the u equals is going to be the x terms themselves. So this will be 2x squared plus 3x. So we can find dy by du. You notice this part's always quite simple. So we'll differentiate sine, we get cos, and then we're going to do du by dx. So we've got 2 times 2 is 4, reduce the power, 3 times 1 is 3, reduce the power, and the x goes away. So now we can do dy by dx, which is going to be our cos u, multiplied by 4x plus 3. Put that in brackets, we'll multiply the whole thing. Now there's a few things we could do next. So we can put the u back in, and we could have 4x plus 3 multiplied by the cos of u, which is 2x squared plus 3x. I've written the other way around and put the x terms at the front, just because I don't want the two brackets next to each other. I don't want you to think, that it's going to be a kind of quadratic you can expand. Now, we could do more things here. So, for example, you could multiply 4x by cos and have 4x of cos plus 3 of cos. So you could take extra steps like this. But again, for these questions, I'm just going to keep it in the kind of bracket form we get to. So we're just going to be focusing on the actual chain rule part. For the next question, we're looking at cos instead of sine, and we've got y is equal to the cosine of 3x cubed plus 2x. So we want to have y equals our bit of trigonometry, and then we want the u, which is the kind of angle part that we took out. So we can differentiate dy by du. You differentiate cos and you get negative sine. Then we have du by dx. So 3 times 3 is 9, reduce the power by 1. 2 times 1 is 2, reduce the power. And now we've got our answers. We find dy by dx. We multiply those together. It's going to be a negative sine u multiplied by 9x squared plus 2. So we'll rearrange this. We'll put the x part first, so 9x squared plus 2. We're going to make it negative as well, so we'll put the negative sign on the front, this negative sign, and then we'll have the sine bit next. So it'll be sine of u, and remember that u was 3x cubed plus 2x. Then again, there's more things you can do next. You might want to multiply at the brackets, for example, but we're going to leave it here. So now we get a little bit more complicated. We've got y is equal to 2 cos ln x to the power of 7. So we're going to have y is equal to 2 cos u, and u is equal to ln x to the power of 7. You differentiate dy by du is going to be equal to, you differentiate cos, you get negative sine. So it's going to be negative 2 sine of u. And then differentiate u. You differentiate ln x, you get 1 over x, but we've got a 7 in there, it's going to be 7 over x. Alternatively, you can write that as 7 to the power of negative 1 on the x, because the over x is the denominator and the power minus 1, they're the same thing. So now we can find dy by dx, and that's going to be negative 2 sine of u multiplied by, now it depends on which way this is going to be easy to work with. Now in a lot of questions 7x and minus 1 is easy to work with. For this one I think actually we can get away with 7 over x. So let's see how that works out. So we have negative 2 times 7 is going to give us negative 14. I've got the sine of u, and u was ln x to the power of 7, and then that's going to be divided by x. So this version is probably going to be the simplest form. Alternatively, you could write negative 14 x to the minus 1 and then write the sine part. So again, there's multiple ways that this could be written. So now moving on to our last example like this. So we've got y is equal to 8 lots of ln sine of 2x. So this time for the y equals, I want to use the most outmost term that's happening, and that's the ln. So we can write that y is equal to 8 lots of ln u. Then we can write that u is equal to the sine of 2x. So we can do dy by du. So we're going to have 8 lots of, and when you differentiate ln, you get 1 over x. But this time it's ln u, so it's going to be 1 over u, which we could write as 8 over u. Then we differentiate u, we've got sine of 2x. Differentiate sine, you get cos bringing it to 2, so that'll be 2 lots of cos 2x. So now we can multiply them together to get dy by dx. So that's going to be 8 over u multiplied by 2 cos 2x. So 8 times 2 is 16. It's 16 cos of 2x. And it's going to be all over u. And u was the sine of 2x. Now, again, there might be more steps after this. When you've got kind of cos divided by sin, you can get things like tan and sec. There could be more things to do after this. But again, this is the chain rule part of the question. For the hard questions, we'll look at some more complex special cases. First, we'll look at E. So we have y is equal to 3 lots of e to the power of 2x. And again, we can split this into a kind of special number section and a power section. So we're going to have y is equal to 3e to the power of u, and then we're going to have u is equal to 2x. So differentiating the kind of main part of this and the power separately. So dy by du, that's going to equal 3e to the power of u. Remember, when you differentiate e, it doesn't change. It stays the same. Kind of the gradient, the expression of the gradient and the line itself are the same thing. Another point here is dy by du. The y and the u are unknown variables. And just make sure you know that e is not an unknown variable. E is actually a number. You know, it's like 2 point something. It's a number like pi. It's an irrational number. Next, we can differentiate u, and that's going to be 2. So for dy by dx, the gradient of this line, we need to multiply those two bits together. That's going to be 3e to the power of u times 2, which altogether will be 6e to the power of u. So now we just need to put u back in. So that'll be 6 lots of e to the power of 2x. And if you think about this, think about how we differentiated e previously. And I said, if there's a number on the power, you can bring that out. Well, you can see that happening here. We started off with 3e to the 2x, and we finished with 6e to the 2x. So that 2 has come out to multiply the coefficient at the front, like we've been doing before. But this time, rather than remembering that's the case, you can see it actually happening using the chain rule. Next, we have y is equal to ln of x cubed plus 3x. So again, you know, we can use the kind of u things to get rid of the powers, but we can also use it for more complicated things like trigonometry, or in this case with a log. So we can say y is equal to ln u, and u is equal to x cubed plus 3x. So the u part is always usually the bit with all the x's in, and the y equals bit, that's the kind of bit with a kind of complicated bit, the power or the trigonometry or the log or e. So we can differentiate dy by du. Differentiate ln, you get 1 over. So that's going to be 1 over u. Now differentiate u, and it was 3x squared plus 3. So we want to multiply those together for our answer. Dy by dx is going to be 1 over u multiplied by 3x squared plus 3. So that's going to be 3x squared plus 3 all over u. And we can substitute u back in. It's x cubed plus 3x. Now, at this point, there might be other things you can do. You might want to factorize the numerator and take 3 out as a factor, or take x out of the denominator. There's other steps you can do here, but as usual, we're focusing on the chain rule. Any extra steps, the question is going to ask for it. It'll ask for the answer in a certain form, or it'll be asking for something else to happen next. Next, we have y is equal to ln 2x plus 5. So let's split that up in 2 bits. Y is equal to ln u, and u is equal to 2x plus 5. So differentiate ln. That's going to be 1 over. So it'll be 1 over u. Differentiate u, and that's going to be equal to 2. So for dy by dx, multiply those together. We'll have 1 over u multiplied by 2, which is going to be 2 over u. So we can substitute u back in. That's 2x plus 5. And there we have our final answer. And again, after this point, you might have to do other things. It might be you can use equivalent fractions, you can use simplification of fractions, you can factorize the fractions. So there might be other steps. Next, we have a root. We've got y equals the square root of 7x cubed plus 6. Now, there's a few ways you can think about this. So, for example, you can just say that y is equal to the root of u, and u is equal to 7x cubed plus 6. Alternatively, you could rewrite this. You could say that y is equal to 7x cubed plus 6 to the power of a half, because a square root and a power half are the same thing. That will give you y is equal to u to the power of a half, and u is still going to be the same thing, 7x cubed plus 6. Now, no matter which the two ways you represent this, you're still going to get the same answer. What you'll find, though, is when differentiating, it's going to be easier to have a number on the power. So dy by du, and what you do, you're going to multiply the power by the coefficient. If there's no coefficient, it's by 1. So 1 times a half is a half. And then you reduce the power by 1. So a half take away 1 is going to be a negative half. Then we have du by dx. So 7 times 3 is 21. Reduce the power by 1. Then we have 21 x squared. So for dy by dx, we multiply those two answers together. So we have the 21x squared multiplied by the half u to the negative half. Now, for a final answer, it's going to look a bit odd at first. We can write 21x squared all over 2 lots of the square root of u. So where does this come from? So you can see where the numerator is coming from. It's a 21x squared. That's fine. What about the denominator? So it's all about kind of rearranging this back. Remember at the start, we changed a root sign into a power half. So the first thing we've done is we changed the power half back into a root sign. So rather than having u to the power of a half, we've got the square root of u. The other thing that we've done is that we've put the entire u section as the denominator. And you can do that if you take the negative out of the power and the reciprocal of the coefficient. So a half has become 2 over 1, we flip the fraction upside down, and the negative power has become a positive power. And now all we need to do is we can substitute in u. So we're going to have 21x squared all over 2 lots of the square root, whatever u is, and u was 7x cubed plus 6. And so that is our final answer. Now it's getting a bit cramped at the bottom with all this working out. So let's write at the top nice and neat. 21x squared all over 2 lots of the square root of 7x cubed plus 6. And that was dy by dx, differentiated version. So let's look at another example like that. So I'm going to say that y is equal to the cube root of 4x cubed plus 6x. So we can write this as y is equal to u to the power of a third. That's the same as saying the cube root of u. It's going to be easier to work with a third when we differentiate. And then u is going to be equal to 4x cubed plus 6x. So we know the u part's going to be really easy to deal with. Du by dx is going to be 12x squared plus 6. The y equals u part's going to be a little bit more difficult. So dy by du is going to be equal to, so we're going to take the third down, so have the u, and we're going to take 1 away from a third. That's going to give us a negative 2/3. What we're going to do is rearrange this now into a format that's going to be easier to multiply with our dy by dx. So we've got a negative power that should be telling you it's going to be a denominator. We take the reciprocal of the coefficient, it's going to be 1 over. So a third becomes 3 over 1. And then the u is going to become a u to the power of 2/3. Now, a power 2/3, that's going to mean the denominator is the root, so it's a cube root, and the numerator is the power. So it's 1 over 3 lots of the cube root of u squared. Those two expressions mean exactly the same thing. So now we can multiply them together. We're going to have 1 over 3 cube root u squared multiplied by 12x squared plus 6. So we do the multiplication, it's going to go on to the numerator. So our final answer is going to be 12x squared plus 6 all over 3 lots of the cube root of u, and u was 4x cubed plus 6x. And all of that actually is being squared as well. Now, there's a lot going on with that denominator with lots of powers, and so there could be multiple further steps. So you might want to expand the quadratic, then you might want to use your laws of indices to kind of combine the powers together and then simplify that in some kind of way. But again, with most of these questions, we're focused on the chain rule. We've done our chain rule section, but always have your mind open to there might be a few more steps in terms of simplifying this.
Ouch! This is why in some videos I have unexplained scratches.